Okay, so the next lesson talks about splitting data. And this is a topic that's very, very important, but sometimes neglected when talking about convolutional neural networks. And so, convolutional neural networks, or CNNs, as they're commonly referred to, are a subset of what is called supervised learning. And I'm just going to go ahead and abbreviate that. And so, supervised learning are what CNNs are a part of. And essentially, that means that a machine learning model has a date. I'm just trying to color that arrow. A machine learning model basically has a very, very large data set. And so pretty much all machine learning models start learning off of data, just like the human brain does. And so, for example, let's say that we had pictures of dogs and cats, right? 100,000 pictures of dogs and cats. You can find those online. There's different methods of acquiring data. One method is using a website called Kaggle, which I recommend for future projects. But essentially, once you have that data, the model creates different types of machine learning architectures. And they're able to actually get numerical value from that data, like the pixels, which we talked about in the previous lesson. They can actually start finding patterns and trends among them. And then the model, after learning on the data that you feed it, it's actually able to perform on samples that it hasn't seen before, because it starts learning about, what makes a dog look like a dog or what makes a cat look like a cat. Then we give it a new picture of a dog or a cat. It can say, oh, there's like whiskers on the cat, or the dog has really big ears, or something like that. And so the model is being supervised in its learning. That should be actually an L. I don't know why that's a U. Let me just rewrite this actually. CNNs, supervised learning. Then you have CNNs underneath those. Basically, that means that you are providing the data set, and there are different types of data sets actually. And so there are three types of data sets that are most commonly used when you're creating machine learning models. There's the training data set, which I'll talk about shortly, the validation data set, and the test data set. So what's the difference between these? And I found this graphic over here, which is really, really nice and pretty helpful, I think, in visualizing this. And so when you have, your data set, let's say that you have like 50,000 images, right? So if you're going to train a machine learning model, how many images are going to go where? And so there are three steps to it. The first one is the training data. And the machine learning model obviously has to learn, just like the human brain, it needs to learn somehow. And so that's where the training model comes in hand. Right here, you basically put your training model in, and you have the training model, and you put your training data set into that model. And so let's say, I'm just going to use 1,000 images as an example. We have a data set of 1,000 images, and let's say that we're going to use, in this example here, 80% of it for training. So that means we're going to have 800 training images. And so what that means is just that the model is going to learn from those 800 images. But let's say that the model only knows those 800 images. If I give it a new image, it just doesn't know what to do because it's only seen those 800 images. And so this machine learning model is trained over what are called epochs or epochs. And those are basically just a duration of time. And you'll kind of see in the Google Colab exercise what an epoch looks like visually. And so over a certain number of epochs, this model will learn what those 800 images look like. But if we want to actually validate how it's doing so far, to see how it does on different types of data sets, we can use what are called validation data sets. And so we take the original 1,000 images that we had, and we take 10% of those for validation. What that means is just that, we have 100 images for validation. It's just that at the end of every epoch or epoch, we now, instead of just looking at the training data, we take a moment and we test the model on a validation data. Basically, that means that we're going to show it a sample that it hasn't seen before, and based how that model does, for example, let's say that this validation data set has a lot of dogs, and the model just does horribly on that, then we know in the next epoch we need to focus on dogs. And so when you look at the Python and TensorFlow code, it really just handles that for you, but it's really important to understand what's going on with the training validation set. And so the training and validation set, which is steps 1 and 2, these are just in the general training phase. But what you really need to think about is that last phase at the end. And so let's say it does really good on the training and validation data. That doesn't really show you anything because you're still kind of regurgitating the data that you had before. But what you want to do at the very, very end is what is called a test data set. And essentially, you're going to take another 10% according to this example that we're using here. That's going to be another 100 images. And after the training is finished, after the model is finalized, just to see how it finally does, we're going to test that model on a new set or a testing data set, and let's say that we get a 96% accuracy, well, the 96% accuracy is the test accuracy. And that is the accuracy that we're actually going to end up using compared to what we get in the training phase. And so let's say in the training phase we get 100%. Well, if we train it for long enough, it's just going to keep repeating the same info, right? It's just going to know exactly what's going on. But when we look at the test set, we can say, okay, this is how it actually does. For a certain extent, you're probably wondering, well, why don't we just use the validation data set as well? The truth is that we can use the validation and testing data set to see how the model does throughout each epoch and at the end. So that's essentially testing data, training data, and validation data. Most of the time, you're going to see that the models and stuff you use, they definitely have, a majority of it being the training data just because the model needs to learn. And so you're going to spend a majority of the data on training, but at the same time, it's really important to not neglect your validation and testing data set because those show you how your model is truthfully accurate, not just on the sample you've given it. Thank you.